Hello and good morning or a good afternoon, and welcome to Fronius webinar for this week. Today we'll be talking about Fronius system design tools. And joining me today are my colleagues, Cyprian Okolo, our technical sales advisor for the Western African region. He's based in Lagos, Nigeria, as well as our new colleague for the Southern African region, Byron Kotze. He's a TSA for Southern Africa, for the Southern African region. He's based in Johannesburg, South Africa. And myself, David Mongi, I'm the technical sales advisor for the Eastern African region. I'm based in Nairobi, Kenya. So I'll be doing the first part of the webinar, and then later on I'll hand over to Cyprian to continue and do the last part of the webinar. And then Byron will be in chat support. So if you do have any questions during the course of this webinar, please feel free to post all your questions, and he will do the best he can to answer all the questions. So the agenda for today, we are going to be discussing, like I said, the Fronius design tools, the available tools that you can use to configure PV systems. And we have three specific tools that we are going to be talking about today. Number one is the Fronius Tauro.configurator, and then we will also do a brief demo on the Tauro.configurator. We will also do and look at the solar.configurator and how to access the solar.configurator as well. And then later on, Cyprian is going to do a much more detailed presentation with the Fronius solar.creator and do a live demo as well. So without much ado, let's get started and look at the Fronius Tauro.configurator. So as most of you already know, Fronius recently introduced commercial inverters. And these commercial inverters are available in, let's say, 3 standard variations. And variation number 1 is what we refer to as the Fronius Tauro standard. And this is in the power class 50 kilowatts. And with an operational voltage as far as MPP is concerned from 400 to 870 volts. This inverter has 3 MPPTs, and you can see the breakdown of the current capacities of the 3 MPPTs, starting with 36 amps for the first and the second MPPT, and then 72 amps for the third MPPT. We also have an eco variant of the Tauro inverters, and this eco variant has 2 power classes in it, and power class 50 and 100 kilowatts. The operational voltage from 580 to 930 volts. The big difference between the Tauro standard and the Tauro Eco is that the Tauro Eco has 1 MPPT for each power class, that is 50 and 100 kilowatts, and maximum input current for the 50 kilowatt is about 87.5 amps, and for the 100 kilowatts is about 175 amps. When it comes to the design, and the reason we are mentioning this information regarding the Tauro inverters is because when you're using the Tauro configurator, you need to have an idea which kind of a system you're going to be designing. So with the Tauro commercial inverters, you can achieve a topology that is either central oriented or decentralized. So when you talk about a central system design, we are talking about a configuration of inverters that would see the inverters situated next to each other. So that is, they are centrally placed. And in this case, if you have a field, as we can see here, of 150 meters by 200 meters, you would then have your PV array distributed across this field. And this means that from the strings, you have DC combiner boxes that then will be used. You'd use plus and minus cables to transport the DC power to the inverters. On the flip side, when you're talking about a decentral system design, is whereby in the same field that you have your PV array distributed, you have the inverters positioned next to the array, and therefore you have the possibility to connect your DC power directly to the inverter without the need for DC combiner boxes. And therefore, it means that in contrast to the central design, the AC power cabling is much longer, because we can see that in the central design topology, the DC power cables run a much longer distance than the AC cables. So the flip side is true for the decentral, and therefore, when you now go to the solar Tauro configurator, you will have the option to choose a Tauro inverter that has the capacity of AC daisy chaining. So that means that you can combine blocks of up to 200 kilowatt on the AC side of the Tauro power and have them connected by the same AC bus and then going to the feeding point. When it comes to the central design, you have a lot more flexibility as far as other choices that you can have, even having integrated AC disconnectors inside the inverter. So in terms of the major differences, like I mentioned for the pre-combined and the direct versions, so the direct means that you are able to connect your DC power directly to the inverter, and the pre-combined means that this inverter is designed for use with DC combiner boxes. But in terms of the pre-combined version, which is the photograph to the left, so you can have a maximum of up to 6 cable glads in the inverter, depending on the power class. On the AC side, you are able to connect up to 240 millimeter square of AC power cable, and all the cable glads for the AC and the DC side can be integrated depending on which variant you select, as we are going to see later in the Tauro configurator. When it comes to the direct variant, so you can see that the inverter has MC4 plugs that are integrated, and therefore this makes it possible to use string cabling directly to the inverter by connecting matching MC4 plugs. On the AC side, you can still connect up to 240 millimeter square. And for this particular inverter, you are going to need to select also in the Tauro configurator string fuses. So string fuses can be freely selectable depending on the amperage of the PV modules that you're going to be using. So when it comes to now configuring your Tauro inverters and selecting which variant that you're going to order, because in a nutshell, the Tauro configurator is going to assist you to communicate to Fronius cells in terms of the variant and the options that you want to go with for your Tauro inverter. So what I would like to do after this is that I'm going to show you a brief demo, but also in terms of designing with using other advanced third-party tools. The Tauro configurator, the Tauro inverters are already fully integrated into, for instance, PV-Syst as well as PV-Sol. So there is no limitation there if you're using third-party design tools. So what I'd like to do at this point is to show you a quick demo of the Tauro configurator. And for the Tauro configurator, you do not actually require to have an account. So this is a free tool that is accessible for anyone to use. And all you need is to access this website, that is the Tauro.configurator.fronius.com. And from there, you're able to start your configuration. So once you click the start button, the first section is the system design. And therefore, as I had mentioned earlier, you can have the possibility to do 2 system topologies, and one is centralized and the other one is decentralized. If you're still not clear on these 2 variations of system topologies, you can click on this info button, and there is a description within the Tauro configurator on what that centralized topology looks like. Likewise, you can also check what the decentralized topology looks like. So just like I had explained before, so just to double check that you're doing the right thing. So in this case, we are going to go for centralized design. And once you select the centralized design, then you have the various options of the Tauro commercial inverters that can be used with a centralized topology. So we are starting with a 50 kilowatt inverter. This is a standard version that has the 3 MPPTs, and then you have the Echo with 1 MPPT, and then you have the 2 bigger power classes of 99 and 100 kilowatts. So you have to choose one inverter at least, And then, because in this case, we are going to do a pre-combined inverter, then you can see that the information from the configurator tells you that you do not require inbuilt fuses because your DC side protection will be done at the combiner, DC combiner box. Then you click on next, and then you have to choose your SPDs. So the Tauro inverters will come as standard integrated with SPDs. The only choice you have to make is if you want to integrate SPD type 1 plus 2, or you want to integrate type 2 only. So likewise, you can see there are info buttons here. So if you click on any info button, for instance, for type 1 plus 2, and it also shows you here the article code that you can use to buy these SPDs from Fronius. So it gives you a description of what the type 1 plus 2 is all about, and likewise for type 2 only. But for better protection, let's go with type 1 plus 2. And then the next step, you are required to choose the AC connection variation that you want for the Tauro inverter. And you have 3 possibilities for this variant. So you have AC daisy chaining, you have single core where you want to use single core cables, and you have the possibility to bring a multi-core cable and then just have one cable gland where the multi-core will go through into the inverter. So this makes it very, let's say, flexible when you are designing the Tauro inverter, and you can order the exact kind of options you want directly from Fronius. So if you, for instance, are going to design maybe a system with 2 by 100 Tauro inverters, you can choose AC daisy chaining. And what does this mean? It means that, like I had said before, with a power block of about 200 kilowatts on the AC side, you are able to connect these 2 inverters together, and therefore significantly reduce on the cost of AC cables, especially when your AC cabling distances are quite long. So let's go with AC daisy chaining. And the last section is about the AC disconnector. So we can see that because we have chosen AC daisy chaining, and the space inside the inverter that can accommodate an AC disconnector has been used by the daisy chaining option, then the configurator tells us that this AC disconnector is now compatible with the variant that we have selected for this inverter, and therefore we choose next. Once you click next, you're going to see what your configuration looks like, what you have chosen. For instance, for this particular configuration, we have chosen a Tauro Eco 100, and the system design is centralized. You do not require fuses, and surge protection you have chosen type 1 plus 2. AC connection we have chosen AC daisy chaining, and therefore it comes without an AC disconnector. So once you verify, here you can add, like I said, if you want to design a system with 2 inverters, here you can increase the quantity to the number that you want, and then you click on next. So once you click next, you go into project data where you give your project name here. So here we can say webinar training, for instance. And then we can say which country options you want. If you have specific country options, in this case, I'll say Kenya, and the location is in Nairobi. And then which system size you are designing. So we have 200 kilowatts, and it also allows you to choose accessories. Let's say you want to do the mounting of the Tauro's inverters on the floor without having to mount them on a wall. So here you can choose mounting racks. So if you click on that, you can see how the mounting racks looks like. So if you're going to design an installation with 2 inverters, then you need 2 pairs of these mounting racks. So we can say here, you're going to need 2 of those. Protection hoses, if you require, within the compartment of the AC connection area, the temperatures can get quite high. And if you're not sure that your cable insulation can withstand this kind of temperatures generated there, then you can order also extra protection hoses for the cables that are going to be used there. If you want to have an AC disconnector locking device, so if you want to see what that looks like, on the inverter itself, you have some DC disconnectors. So you can order also locking devices for these DC disconnectors so that nobody is able to turn off the DC power when it's not required to be off. But in this case, let's just order the floor mounting racks. And then once you are done with this, you have the possibility to export the configuration by email. You copy to clipboard or import or export a CSV file. So in this case, once you click on email, it goes to your email server, and then you're able to send an email with the correct configuration that you want to order for the Tauro inverter directly to Fronius. So in this case, you are able to avoid making any mistakes for ordering the specific Tauro variant that you want. So therefore, the Tauro configurator becomes a very, let's say, essential tool for your design work, and to make sure that what you are ordering from Fronius will not come to give you troubles in the field, depending on how you wanted your system actually to look like. So, and I think that brings us to the end of the Tauro configurator. So we go back to the main presentation and look at the solar configurator. So the solar configurator is actually also a free tool that is available from Fronius, and has been for quite some time the only, let's say, string design tool available from Fronius. But now we have a more advanced tool that my colleague Cyprian will be talking about. So let's have a look at the solar configurator. And the version that has been there up to date is a configurator version 4.0. And this is now fully integrated in the new design tool that is the solar.creator. So when you open the solar.creator, you are going to see on the right hand side top corner, you can see quick PV design. So this refers to the Fronius solar configurator. So within the solar.creator, you're able to access this tool without having to do a comprehensive system design. But in a nutshell, like I mentioned, it makes your dimensioning of the PV systems fast and easy. So you can do very tailored PV design, system design for your customers, depending on what your customers want to use. And this comes especially in terms of verifying that your string design for a particular Fronius inverter is correct for use. And then, of course, this tool, importantly, is 100% free of charge. As you may know, all other professional design tools that are available in the market, you have to pay a certain premium for. Maybe that is renewable every year or per license, depending on how the sellers of that particular tool want it to operate. But when it comes to using the solar configurator, you have to input several key data, and there are some mandatory fields that must be entered. So the first section will be the PV module area. So with the PV module area, you have to select which module you're going to use from which manufacturer, the model of the module that you're going to be using, and the quantity. So you enter the number of PV modules that you're going to use. You can enter by MPPT1 and MPPT2 if the inverter has 2 MPPTs. And then you can select the country where you want your system to be installed. So here you select maybe Kenya or South Africa or Nigeria, and then all the inverters that can be used in these regions will be activated. And then the last section you have to select for the solar configurator is give your project a name, if you're going to do a system with storage or not. So if you're designing a system using the Gen 24 Plus inverters, you might want to integrate a battery storage or not, so it's not a must. And also you have to give an indication of how much power you're going to consume annually. So this helps to calculate the self-consumption levels as well as the self-sufficiency levels. And then of course you have to enter what is your load profile. Is it family or is it employed? So the difference that makes is that, especially when you design a system with battery, is that if you say employed, there is a lot more excess energy that the system can use to calculate what is your self-sufficiency level, because most of the excess energy is going to be stored in the battery system. If you, on the other hand, you choose the load profile family, it means that most of the PV energy that is generated during the day is directly used by whatever appliances are running during the day. So you can progress once you have entered all the key data, and then the configurator is going to show you various options for string design that are possible with that particular inverter that you have chosen. So it increases by inverter ratio. So we can see here that we are starting with a possibility to connect for this particular design 32 modules up to 38 modules. So you can see here that we have an inverter ratio of 101% and a maximum of 120%. So I believe Cyprian also is going to be mentioning and defining what this inverter ratio really means. So depending on the particular configuration you want, you can also see the string configurations, which is actually very, very critical for that particular inverter, how the modules and how many strings can be connected for each MPPT. So in terms of interpreting the results, it would mean that, for instance, where you have 32 modules, this will be the number of modules that you're going to connect. And in terms of inverter ratio, compared with the AC output capacity of the inverter, this is about 101%. You're also going to see for a selected storage, what is the self-sufficiency level. As we can see here, calculated already 75%. And what is the own consumption levels? So we can see about 30%. And then what would be the optimal storage if you have a system that you have designed with the storage. And most importantly, for the solar configurator, you want to verify that your string design is going to work with that particular inverter. So in this case, we can see that for the 2 MPPTs, we have the possibility to connect unsymmetrical number of modules. So for MPPT number 1 or PV1, we are connecting 1 string with 20 modules. And for MPPT number 2, which is PV2, we are connecting 1 string with 12 modules. So you have the possibility to vary in this case. And this is very, very helpful if you have, for instance, a roof design that is not able to accommodate equal number of modules on either side. So therefore, the solar configurator, is able to verify whether these string variations would work with that particular inverter without affecting or damaging the inverter. So when it comes to generating a report that can be issued to your customers, you can do that out of the configurator tool, and you are able to see, for instance, the specifics about the string design, which is critical. So we can see here that for this particular string design, where we have 2 strings, one with 20 modules and the other with 12 modules, that MPPT number 1, which is PV1, is connected to 1 string with 20 modules with a voltage at maximum power at 70 degrees of about 557, and open circuit voltage at the lowest possible temperature of about 896, but MPP voltage at 644. So this data is very well generated, and when you are going to now connect your string, you can actually use a multimeter to confirm the string voltage as calculated using the solar configurator. In addition to that, you can also generate a proper PDF report for the entire design. Unfortunately, it's not very well visible here, but outside of the string the solar configurator, you can generate this kind of report that is going to show you the exact design that you're working with, and give it maybe to your installation team, so that when they go to the field, they're not going to make any mistakes. So like I said, if you want to access the solar configurator, you can do this directly from the solar creator tool. So once you click on the website for the creator, you're going to go to this landing page, and you have to create an account for this solar creator. Because the other difference now between the solar configurator and the solar creator is that for the solar creator, it's now possible to create an account, because you can have quite a number of systems saved up, and therefore that improves on your system and data security for the systems that you are designing. So I believe also here my colleague Cyprian is going to show you briefly how the solar configurator looks like within the solar creator tool. So with that, I've come to the end of the first section, and I'll be handing over to Cyprian to do the remaining bit of it. So Cyprian, if you can take over from here.
Yes, indeed, David. Thanks a lot for your wonderful presentation. And of course, I will be continuing from this point. And we shall be taking over and then discussing the solar creator. So for the solar creator, just like David has already introduced, it is basically a Fronius, a flexible and user-friendly online configuration tool provided by Fronius, which is used for comprehensive design and simulation of photovoltaic systems in combination with electrical loads, storage facilities, and of course, EVs. So we're going to delve into it right now to discuss its features. And then features include, well, first off, I must mention that the Solar Creator was actually, it came about with a firm interest and desire to have something much more detailed than the solar configurator. And just like David has mentioned already, you can no longer, there's no direct link to the solar configurator anymore. You'll just have to get access to it via the solar creator. So continuing with the features of the solar creator, and of course, a very important improvement that have been made on it with reference to solar configurator is that you can have irradiation data of a particular location of your choice, where the system is going to be installed. And then, of course, you can connect to Google Maps, and of course, where you can obtain the data of that particular location, and of course, weather conditions. And of course, you can also determine a location by simply entering the address or the coordinates of that particular location. Good. What about consumption? So it is possible here to have a visualization of the load profile for both weekly and annual basis. And then you can determine the energy consumption with the help of a predefined load profile. We're going to see that later on during the demo. And then, of course, it's also adapted to the location of the system in question. So for modules, you can connect to an extensive and up-to-date module database, which is constantly updated from time to time. And then, of course, you can integrate user-defined modules. So this comes in handy when, for any reason, you don't find the data of the module you want to make use of. You can, of course, enter a user-defined module specification into the area for you to integrate your predefined modules that you want to make use of. Good. So next up is inverter design. So in this case, there's an automatic inverter suggestion. So it automatically makes recommendations for the inverter to use for a particular system during your design. So there's also easy determination of the optimal design results, and of course, flexibility in inverter selection. So it comes up with a whole range of inverters, and then making it possible for you to make your selections from an array of inverters made available. Good. So then you also have the possibility to apply other or include other sectors in one application in the same solar creator. What does this mean? It means that you can actually have a residential solution, commercial solution, storage solution that is a system designed with battery backup. You can also have the home pilot for generation of hot water. And then, of course, you can also have your EV, that is the watt pilot, also integrated into this. So it comes as a wholesome solution, a wholesome Fronius solution for your system design. So we will now be going into it very soon after a few slides. So in terms of determining how efficient the system is, of course, in economic terms, you're going to have there's a possibility of you having a detailed consumption and load profile detail or analysis. And then you have information on power purchase costs, feed-in tariffs, and system costs. Of course, this information at some point you'd have to obtain it from what is obtainable or available in your country or region. And then by the time you enter it, you would now have an overview on the amortization of the PV system in question. Good. Afterwards, you can now get a very detailed report on the system you have designed, giving you all the important energy and economic key figures. You can, of course, visualize all the energy flows in the system, and of course, also have a view of yearly yield simulation. Good. So having said that, we shall now so let's now have a view of the Solar Creator, and then great. Go have a walkthrough of the app. So first off, it's going to bring you to the landing page where you can now log into your own account or continue as a guest. So just like David mentioned, it is important to actually have an account, of course, and this you can easily do by simply just registering and opening an account for free. Then if you just still want to test it out per se, you can of course log in as a guest. So let's see what happens if you log into your account, and then I would see the advantages thereof. So logging into your account. So take some time to load up. There it is. So it gives you access to all the systems that you've designed previously. So it's sort of serves as a storage system per se. So it will store all the data of all the designs you've done. So this is not available if you log in from the guest profile. And then just like David also mentioned, this hyperlink here, Quick PV Design, of course, would now automatically link you to the Fronius Solar Configurator. I would have loved to do a live demo here, but because of time constraints, I would have to continue with the Solar Creator. But here, just like David has described, you can now make all your selections and then do your string design respectively. So now going back to the Solar Creator, we can now continue with our system design. So like I said, you can start off, of course, start a new project in your account, or if you don't have, you can of course continue as a guest. So just to prove that it is free, and then also to note here that whatever feature is available in the account version per se is also available if you log in as a guest. So logging in as a guest would now take us to the startup page. As you can see here, it's blank because there's no possibility to save any system design on the guest format. But then all the features available in the account version is also accessible here in the guest version. So let's start up with a new project. And then I'll just basically use my default particulars here to make it fast. And then I'll click on next. So just like I was saying, you can have a storage included or integrated, EV, and then on pilot. But for the purpose of this particular webinar, we'll be going with the commercial. So not to say that you can't try or we cannot have all these features integrated. It's going to kind of take a bit of time to have all of them in one design. Okay, so it means that whatever you select, say I want to go with a residential design, of course, with the battery or storage facility, we can actually click both of them and then click on next and then continue. So, but for this particular demo, for this particular webinar session, let's go for the commercial. So once you've made your selection, you can click on next. Good thing here is that I've had numerous occasions where we've had sessions with installer companies on the solar.creator. So please feel free to try it out yourself, play around with it, and then we'll be glad to get your feedback. So for neutrality, I am going to go with, let's say, the South African Rand. Let's see, Byron. So I'll go with the metric, and then I'll prefer going with the Celsius. If you want to go with this as a default SI units for currency measurement unit, that is in length, and then temperature, you can check this box. But if not, you can of course leave it unchecked and then continue with start. So once you click on start, it's now going to take you to the first stage or first level of your system configuration. Now we are basically going to go through these 7 stages: the location, consumption, PV arrays, inverter and sizing, components, profitability, and finally report. So we should go through them one by one. So now, right now, as you can see, we are on the location pane. Now for the location, we can say select, since I've selected South African Rand, we're going for Johannesburg, South Africa. So once you click on the location, okay, we're supposed to enter an address. So this is a default address. I have no idea where this address is, but then of course it's a real address in Johannesburg, South Africa. So you can, you would now go ahead to, we will go ahead to use this address, but of course you can easily type in your address. In case you don't have the full address, you can of course use the map. So this is actually tied to or linked to Google Maps. Once you click on it, it's now going to take you to a Google platform where you can now select your location. And then once this location is selected, it actually comes in with the exact address of this particular location. And then afterwards, it also comes in with the irradiance per year of this particular location. So if you are familiar with this location and feel that this is not the correct enough irradiation for this location, you can of course feel free to increase it in percentage. The highest you can go is 15% increase or 15% decrease. So we shall be leaving it as this, and then continue to grid parameters. So for grid parameters, it is very, very important for especially regions or countries where you're allowed to feed into the grid. It is important to consider inverter country approval. And this is usually obtainable from the grid operators. So you can either consider or ignore, but for regions or countries where you're allowed to feed into the grid, it is very, very, it is recommended that you select this. And then continuing, displacement power factor, you enter it. And then most importantly, if you're allowed to feed into the grid, this is where you can now impute the percentage of feeding. So if there is no limit at all, you can click on this. So this means that you can feed in as much as possible without any limitation. Then if there's a limitation in your region, you can of course enter the percentage limitation that you have for the particular region. If not, that is, if you're not allowed to feed into the grid, then that means there's 100% feeding limitation. So we're now going to leave it at this and then continue by clicking on next. So once we click on next, that means we're done with the location pane. As you can see, it is now checked. So if there's any feature that you haven't taken care of or you haven't made the correct or necessary entry into, this would not be checked, and you would have to come back here to enter all that is necessary, all the information necessary for you, so that you can now continue. So now we are on the consumption level. So for consumption, this basically comes with several load profiles. So you now have to select which one matches your load profile or your nature of consumption per se. So looking at this particular one, the very first one, it says evening peak consumption. So one could liken this to a restaurant per se that are usually kind of busy during the evening every day from Monday to Sunday. We have another load profile here, Monday to Friday, and then evening peaks, Monday to Friday evening peaks, and then Saturday and Sunday midday peaks. So this could represent a profile for, say, a family that goes to work every morning and then come back in the evening and then turn on power appliances, which raises the consumption to its peak for each day in the evening. And then Saturday and Sunday, which are weekends that they are around, you have midday peaks because of their presence and then usage of power appliances. So whichever one fits your profile, you can now make use of it. So I'm going to go with the default profile here already. And then, yeah, so we can now continue. One thing you must note also is that for every profile you select, there is a corresponding default energy consumption per year. So whichever one you select, let's click on this. This is the same. Let's take this. As you can see, it changes for whichever one. So let's just continue. This is just an example. So when we click on next, you can see that you're done with the consumption and it's checked. So next up is your PV arrays. So for the PV arrays, this is where you now select the manufacturer of the module you want to make use of, the particular type of module you want to make use of, and then the number of modules you're making use of. So let's say we have very popular modules. Let's just go for a different one. This time around, say JA. So let's take this and then to select particular module, let's go for the 600 watt. And then this is now where you determine the number of modules you want to make use of. So you should already know this, but then if you don't know, we have a webinar that covers in the system design on how you can actually determine the number of modules you need for a particular system. So please endeavor to check our playlist and then go through this particular webinar. So let's assume here that we're going for 200 modules of this. So if you look here, you're going to see the total power kilowatts peak will be generated here immediately. So if we're done for 100, it will automatically be 60 kilowatts, as you can see. So let's say stick to 200. So that means we're designing for the 120 kilowatts peak system with your module tilt. If you don't know what this means, please hover over this information button here. It will tell you what it means. So this is basically the tilt of the module. And this varies per country or per region, depending on your coordinates, most especially your latitudes. So this, of course, has its own design calculation to ensure that you've done your calculation and then select impute the correct value here. For this, the default is 25, so we'll leave it at 25. And then continue. Module orientation, azimuth is usually 180 degrees. If you don't know what this means, of course, you can hover over the information button here. So this basically gives you the orientation, the module orientation of the modules, and you can have it in the east-west orientation if you like. So for the mounting, we're going to go with the roof mount. Of course, it can be building integrated. It can also be ground mount or freestanding, as the case may be. If you're using a module that is bifacial, please ensure that you impute the bifacial power gain in this column. If not, please leave it blank and then click on next. With this, we will be done with the PV arrays and then we'll be going to the next which is inverter and sizing. So there it is. So we are now on inverter and sizing. So this is where, first off, we'll have to select the inverter ratio. So basically the inverter ratio describes the relationship between the DC generated power and the AC generated power. So for the inverter, our inverters basically have a power factor of 1. So which means that what comes in is what goes out. So that automatically can also mean the ratio of the DC power as against the inverter power. So for this, let's move this. Let's say we're going for 120% inverter ratio. And then, of course, maximum DC voltage for inverter is 1000 volts. So with that, we're done with the inverter ratio. Next up is the module temperature, the range. For South Africa, well, I think let's leave this at 0, let's say, but this might not be so, but then it's an example. So if you have the correct values for possible module temperature, you can now impute it. So let's continue to the next section where we now select our inverter. So from all the selections we've made, the system automatically pops up with, first of all the inverters available, and then checks recommends the inverters that can be used to realize this particular system design, as you can see them checked. If you feel that the inverter range is much, you can of course uncheck some. Let's say we uncheck the Tauro 99, for example, and then just to make the choice margin as narrow as possible, as you can see. So once you're done with that, you can now, or if you want to increase the range, obviously you can, of course, select more options. So let's now go to show calculations. Once you click on that, it would now take its time to now, with the use of all the choices you've made, all the inverted choice range you've made, to now come up with all the possible combinations of inverters that will be available for use to achieve this particular system design. So first off, we will come up with a suggested or recommended system design with 120% inverter ratio. So for this particular recommendation, we're going to implement, or it's recommending the installer to implement 2 units of Tauro 50. And then for details of this, you're going to have 2 strings in PV input 1. These 2 strings, each of them would have 13 of these 600 watts panels connected to it. So you have 2 strings of 13 modules each connected. And then in input 2, you'd have 1 string containing consisting of 9 modules connected to this string. And then in PV3 would have 5 strings, and on these 5 strings we'll have 13 modules. So by the time you add up all these modules, you're going to get 120% inverter ratio. Mind you, this 60 kilowatts peak is for one of the Tauro. By the time you have the 2 installed, you're now going to achieve the 120 kilowatts peak as intended. Good. So this, like I said, is the recommended system design. You can, of course, look at other options. So for this first option, as you can see, it recommends using 2 inverters. For result 2, as you can see, this is result 1. For result 2, it recommends you still using 2 inverters, but this time around, we have different string orientations, as you can see. So depending on what you have on ground in terms of area of installation, say be it roof mount or ground mount, you can now make your choice. Going further down, you can see that for result 5 here, as you can see, we have option of using 4 inverters. So let's click and see. So in this case, it offers this solution using 3 SIMO 17.5s and then 1 Tauro 50. As you can see, clicking on it, it now gives you the detail of this installation per inverter, as you can see. So let's now assume that we're going with the recommended. So one other thing, in case you don't want to use this recommended, yes, this recommended system design, you can uncheck it here by simply clicking on the one you want to make use of. Clicking on it automatically unchecks the one that has already been recommended. So going with the recommended system design, let's click on next. So it would now ask you to add whatever, all the accessories per se, or all other sectors that are available. So be it the battery, the smart meter, the watt pilot. So if we had selected storage, watt pilot, that is for EV, and then home pilot for generation of hot water, this would have all been active. And then this is now where you integrate them into the system design. But since we didn't, we're just going to make use of the smart meter, of course, which is necessary. So we're going to add our smart meter and then go with 1 unit of the 5K. And then here, with that, you've come to the end of the components part. So it has automatically taken you to the profitability section. And now this is where you can now enter all the necessary information to calculate that would help in calculating the amortization of this particular system. So electricity costs for South Africa, not too sure, but then per kilowatt hour, let's just say 2.5 rands per kilowatt hour. Not too sure if I'm correct here, but then just as an example, so let's say it has an increase rate of 1%. Since we have indicated here that it is tax inclusive, there's no need to add any figure here. Let's continue to the next section, feed-in tariff. Feed-in tariff is usually around half of the tariff cost. So let's say this is 1.25, and continuing duration, this could be, you could say 20 years, let's say, duration for this, for the calculation. And then total system costs, this is also an example, but not doesn't mean that it is exactly correct. So let's just say 5 million rand, for example, and then just leave all the other details for calculated periods. It could be shorter or longer. So once you have entered all the basic information, you can now click on next. So once you click on next, it's now going to generate a detailed report of this particular system. So as you can see, it has indeed come up with a detailed report of the system. So first up, you have your yearly irradiance, your grid, the phase type, single phase, because we actually selected all. So this is basically, of course, a 3-phase system. And then your energy consumption per year, as was generated by default, and then cost of energy, as we entered earlier. So in terms of power, you have for self-consumption, because we didn't select any of those accessories or any of those sectors for inclusion, the battery, home pilot, or watt pilot. If we had done that and imputed all the necessary figures, we would have a figure here for self-consumption. Self-sufficiency is 40%. And then let's now look at profitability. So savings own consumption per year is given at 4,591 rands per year. Gain from feeding is 235,000, that is if allowed. And then return on investment here is 21 years. Of course, it can be way, way shorter than this when the correct figures are entered. But another important figure here is that the savings on CO2 is 110, approximately 107,000 tons per year. Good. Going next to the energy flow, it gives you all the necessary information in terms of self-consumption, direct use, and then power fed into the grid. So like I mentioned earlier, this is 0 because we haven't chosen any self-consumption sector, be it storage or watt pilot or home pilot. And then for consumption, just to show how the consumption is covered, this is it, as you can see. And then it also gives you the total irradiance values across the year from January to December. So it gives you the solar irradiance and then the energy consumption, as you can see. So this is quite a very, very detailed report. It now also gives you the detail of your PV arrays, the tilt angle, the module orientation, the module type and brand, and then of course your PV power generated or generation. Then for the inverter info, it is also here, and of course the orientation per string, as you can see. Yes, so of course it included the smart meter, so it has also included the details of the same smart meter. So if you want to have this downloaded, you can of course click this link here. It will download this report, making it ready for you to view in PDF format. So clicking on it should take us to a page where we can now view it. It's going to take some time to generate, but it has already. Okay. Good. So as you can see, it has popped up with a very detailed PDF report. So this you can conveniently, submit or send to your client. So with this, it gives the client the confidence to know that installer has a very good understanding of the system that is intended. Good. So if you would want to send this as an email, you can also send it directly to the email address you want to. And then, with the other details. If you want to continue with the details here, you can select your language. As you can see, select, once you've selected the language, you can go ahead and now send it to the intended address. So yeah, so that's basically it. Like I earlier said, I invite you all to please try your hands on this, and then we'll be more than happy to receive your feedback. One more thing before I conclude on this demo. If you feel you want to make any changes on any of these settings, maybe you feel you want to make any adjustments, please feel free to click on any of the sections that you feel you want to make any addition or any changes, and then you can now make it. And then of course this will pop up with results with respect to the changes that you have made anywhere here. If you want to go back to your system, the original system settings, you have to click on here. Well, this is not an owned account, so it's not going to give you that option. So just in case you wanted to change, say, the company name or your details, initial details, you can of course do that by clicking on this hyperlink here. But that is only possible for an account owned system design. Good. So with that, come to the end of this demo. So I want to believe that you gained pretty much good information here. So we shall now be continuing with the presentation. Good. So I'm going to give you just a brief further information. Yeah. So this webinar and others are available on our YouTube channel, YouTube Sub-Saharan Africa playlist. With this link, you will be able to access all the webinars that we've conducted so far, including this when it is eventually uploaded. In addition to that, you can of course have access to operating and installation instructions on our homepage. And then of course, you can also have how-to and installation videos also, and also webinar recordings on our Fronius YouTube channel. Please feel free to dive in and get all the information that you need in this regard. Good. So with that, we've come to the end of today's presentation. For further information, please feel free to contact the details as can be seen on our screen. And then if you want to reach any of us with respect to the regions that we cover, please feel free to get through to me or Byron or David Mwangi. like I said earlier, with respect to the regions that we support. Great. So with this, we have come to the end of